A refrigeration system removes heat from a low temperature body and delivers to high temperature of body. 1 ton of refrigeration at 1 TR means that the heat removing capacity 210 kilojoule per minute. The ratio of heat extracted in a refrigerator to the work done on a refrigeration is called as the coefficient of performance of refrigeration. And coefficient of performance of COP, reciprocal of efficiency, heat engine is the true. The relative coefficient of performance is equal to actual COP by theoretical COP. The coefficient of performance is always 1 greater than. A 1 ton of refrigerating machine is means that 1 ton of ice when melt from 0 degrees in 24 hours and refrigeration effect equivalent to 10 degree kilojoule per minute. The coefficient of corner say refrigeration in winter will be as compared to COP summer dash higher. The power per ton of refrigeration is 3.5 by COP. The coefficient of performance of a domestic refrigerator compared to a domestic air conditioner is less. The capacity of domestic refrigeration is the range of 0.1 to 0.3 TR. Consider which of the following represent heat pump is the this is the QHQL source పైకి వర్క్ తీసుకుంటుంది. The coefficient of performance CO of refrigeration working a heat pump is given by COP of P, COP of R plus 1. When the lower temperature of a refrigerating machine is fixed, then the coefficient of performance can be improved by lowering high temperature. Air refrigerator works on both A and B. A means a reversed Carnot cycle, B Bell-Coleman cycle. Bell-Coleman cycle is the reversed Joule cycle. Air refrigeration cycle is used in the gas liquefier. The COP of refrigerator working on a reversed Carnot cycle is T1 by T2 minus T1. In a refrigerating machine, heat rejected is heat absorbed greater than. The coefficient of heat pump working on a reversed Carnot cycle is T2 by T2 minus T1. If the condenser temperature is kept constant, the coefficient of performance of a refrigeration cycle increases with the increase in evaporator temperature is S. The evaporator temperature is kept constant, the coefficient of performance of a refrigeration dash cycle dash with the intercase increases a condenser temperature is the decreases. In air conditioning of aeroplane using a air refrigerant cycle is used reversed Brayton cycle. A Bell-Coleman refrigerator working on a condenser air system as compared to open air system as the same range of temperature result in higher coefficient of performance is the agree. A Bell-Coleman refrigeration working on a done air system as compared to open air system the same range of temperature results in the power of per ton refrigeration is lower. In reverse Brayton cycle, the heat absorbed by the air during constant pressure expansion process. In aircraft, air refrigeration cycle used in the because of low weight per ton of refrigeration. An ordinary passenger aircraft requires a cooling system of a capacity 8 TR. A simple air cooling system is good for flight speed is low. The water, alcohol and ammonia have the refrigerating effect different attitude is no. A bootstrap is air cooling system has 2 heat exchangers. The air cooling system mostly used in the transport type aircraft is as bootstrap air cooling. A bootstrap air evaporating cooling system, the evaporation is provided between the second heat exchanger and cooling turbine. The reduced ambient air cooling system has 2 cooling turbines and 1 heat exchanger. The cooling system used for supersonic aircraft and rocket is refrigerating air cooling system. While designing the refrigeration system of an aircraft, the prime condensation is the dash. Mass of refrigeration requirements is low. In a mechanical refrigeration system, the refrigerant has the maximum temperature is between compressor and condenser. In mechanical refrigeration system, a refrigerant occurs liquid between the condenser and expansion valve is true. The expansion valve is the refrigeration control have the flow refrigerant is correct. During refrigeration cycle is rejected as the refrigerant is the condenser. In vapor compression system, the condenser of refrigerant before entering the expansion of the throttle valve is the high pressure saturated liquid. The condenser refrigeration after passing through the expansion throttle valve in a vapor compression system is just very wet vapor. In a vapor compression system, the condition of refrigerant before passing through the condenser is dash superheated vapor. The condenser refrigeration after passing through the condenser in the vapor compression system is the saturated liquid. The highest temperature during the cycle in a vapor compression system occurs after evaporation is fast. The lowest temperature during the cycle vapor compression system occurs at operation. Deformation is refrigeration may be done by stopping the compressor of short period is the right. The formation of your frost and cooling coils of refrigeration is the increased power consumption. In a domestic refrigeration capability to control the flow of refrigeration from the expansion valve of the evaporator. In a vapor compression refrigeration system, a throttle valve is used in the place of expanding because the positive work in the isentropic expansion of a liquid is very small. The coefficient of performance of a vapor compression refrigeration system is the Q8 as compared to the air refrigeration system is high. In a vapor compression system, the condition refrigerant with dry saturated vapor before entering the compressor. The condition of refrigerating as it leaves the compressor vapor compression system is a superheated vapor. The condition of refrigerant after leaving the compressor and before entering the condenser is superheated vapor is yes. In a pressure enthalpy chart, the space of the left of the saturated liquid line represents subcooled required region. The superheated vapor region in a pressure enthalpy chart is represented by the space between the saturated liquid line and saturated vapor line. In domestic vapor compression refrigeration, the refrigeration commonly used in R12. In a pressure enthalpy chart, in the space between the saturated liquid line and saturated vapor line is the present subcooled liquid region is false. The refrigerant A after condensation process is cooled below a saturation temperature before throttling. Such a process is called as subcooling or undercooling. Which of the following statement is wrong? None of this above. During subcooling, sensible heat from a liquid refrigerant is removed. Yes. The subcooling in a refrigeration cycle is the increases COP. The superheating in a refrigeration cycle is the decreases COP. The process undercooling is generally brought about is any one of these above. In order to collect to liquid refrigerant and prevent the going to the advice known as accumulator is used in the suction compressor. A vapor absorption refrigerant uses as a refrigerant is the aqua ammonia. The COP in absorption type refrigeration is given by T3 of T1 minus T2 by T1 of T2 minus T3. During gas charging, as in ammonia vapor compression system, the connection of made the compressor outlet is agree. Oil separator in a refrigeration cycle is installed between the compressor and condenser. The coefficient of performance electroflux refrigeration is the ratio of heat absorbed by the evaporator and heat supplied by the gas turbine. In the vapor absorption refrigeration system, the compressor in the vapor compression system is replaced by absorber generally is the liquid pump. The driver is the refrigeration system is removes moisture in the system is correct. The temperature of ammonia after compression in a vapor compression system is 70 to 110 degrees centigrade. Which of the following statement is correct? All of this above. Which of the following statement is wrong? The effect of undercooling and liquid refrigerant is decreases the coefficient of performance.